Hello everyone, this is Dr. Dhiman, and in this video we will learn about mesh analysis using matrix method. That means we will consider a electrical circuit, okay, and from that we will consider the various mesh currents. Here I have considered I1, I2 and I3. These are the mesh currents for this one suppose first mesh, this one is second mesh, and this one is third mesh. In our previous lecture we have seen that Maxwell's loop current method. We have derived the loop equations for the loop 1, loop 2 and loop 3. Now we will consider some matrix method. That means for this loops we will form some matrix, and from that we will try to find out the loop currents I1, I2 and I3. This will further save time from the Maxwell's loop current method. Here in this figure we can see we have the resistances R1, R2, R3, R4, R5, R6, R7, and we have EMF sources E1, E2, E3. Okay, these are the direction of voltage: positive, negative, plus, minus. That is, positive means higher potential, negative means lower potential. So we have already seen that as per the Ohm's law, what we can write? Ohm's law states that V is equal to IR. This V means voltage, I is current and R is resistance. We can replace with EMF source E for this circuit, okay, and I is the current and R is the resistance. So this can be further written as, suppose R into I is equal to E. This form we will use for this circuit, and we will make a matrix for this circuit, and from that we will try to find out the I1, I2 and I3 value. So for this circuit we have three loops. For the first loop we have current is I1, for the second loop current is I2, and for the third loop we have loop current is I3. Okay, and we have considered all the clockwise direction. So if you consider some opposite direction in one of the loop or any of the loop, then this formula I'm going to derive will be somewhat different. This is as per the Ohm's law. That is, the resistance into current is equal to the EMF. In this circuit we have three loop currents, okay, and therefore we will have the matrix will be of the size 3 by 3. Okay, R will be represented by resistance matrix, I will be represented by current matrix, and E is the EMF matrix. Okay, this R, because we have considered three loops, we will have a 3 by 3 matrix. So from this expression R into I, so this matrix is nothing but this is the R, and this matrix is 3 by 1 matrix is this is I, and this matrix is E. R multiplied with I, then we have here E matrix. Ohm's law in matrix form. R11 is the self-resistance of mesh 1. That is the resistance of loop 1 with respect to loop 1. You can understand like that. R11 means resistance in the loop 1 with respect to loop 1. This is the loop 1. So in this loop, the resistance in loop 1 with respect to loop 1 itself. Okay, so how many resistances will be there? So in this loop we have to compare with this loop only. So this loop, if we compare with the same loop, we will have three resistances, R1, R2 and R3. We have to add them. So R11 is the self resistance of the mesh 1. So the sum of the resistances in mesh 1 will be the value of R1, because we have considered the same loop and we have compared with the same loop. That means the self resistance means we have considered the loop 1 and we have considered the same loop, and we have, these are the common elements, common resistances. So we have to find out the self resistance, therefore we have to add them. R22 will be R2 plus R5 plus R6, and R33 will be R3, R5, R6, R7. Why? Let us see. So R22 means this second loop. This second loop resistance with respect to the second loop, that is the self resistance. Okay, we have termed it as the self resistances of the mesh 2. So in this loop, suppose this is the only loop, no other loop is there. So there are R2, R4 and R5. So here I have written here. And similarly for the third loop, suppose this is the loop, no other loop is there, because we have considered the self resistance, that is the R33. So here we have four resistances, and the resistances are R3, R5, R6 and R7. So here I have written R3, R5, R6 and R7. Okay, so this will be the summation will be the R33, that is the self resistance of the loop tree. In the first part we have seen self resistance of mesh 1, so R22 is the self resistances of mesh 2, okay, and R33 is the self resistance of the mesh 3. R12 is equal to R21 and it will be equal to the minus of sum of all resistances common to 1 and 2, okay. R12 means what we can understand, R12 means the resistance of the first loop with respect to the second loop. That means whatever be the resistances that are common to both the loop or both the mesh 1 and 2, that will be the value of the R12, okay. Similarly the resistances of the loop 2 with respect to loop 1, that means we can say that this is the sum of the resistances. If there are many resistances common to both the loop 1 and 2, then that will be the value of the resistances, and we have to put a negative sign. Why we have to put a negative sign? We have to see here, because you can see in any of the loops, suppose for this resistance R2 is common to both this loop 1 and loop 2. For the loop 1, current is flowing from this side to this side, and for this second loop, current is flowing in the opposite direction. So we have to consider a negative sign. Similarly for all the loops, for the suppose R3 and R5. So for this R3, this loop current is flowing in the upward direction. For the loop 1, it is flowing in the backward direction. So we have to put a negative sign. For this R12, it will be equal to R21 because we have to consider the common resistances in the mesh 1 and 2. 1, 2 means this mesh 1 and mesh 2, okay. Here we have to consider mesh 2, and with respect to mesh 1, common resistance will be similar with R12. And we have to find the sum of all the resistors. And we have to put a negative sign, R12 and R21. That means this loop 1 and this loop 2. What is the common resistance? This resistance is the common resistance, okay, and we have no other common resistances between these two loops. Therefore we will have a value of minus R2 because we have to put a negative sign. So here we will have minus R2. R12 equal to R21 is equal to minus R2. Now let us see. Similarly, we can find out for R23, R32. R23 and R32 means, that means the resistance of the loop 2 with respect to loop 3. The common resistances, okay, resistances that are common to mesh 2 and 3. 2, 3 means, 3, 2 means similar, okay. If we find out the common resistances and if we find out the sum and if we put the negative sign in front of them, that will be the value of this R23 and R32. Now let us see R23 and R32. That means second loop, this is the second loop and this is the third loop. So this resistance is the common resistance between this loop 2 and loop 3. So what will be the value? That is minus R5. So this value will be equal to minus R5. Similarly, we can find out for R13 and R31. R13 will be equal to R31 because now we have to consider the loop 1 and loop 3. Here also loop 3 and loop 1, this is the similar. We have to find out the common resistances to the meshes 1 and 3. That is sum of all resistances common to both the mesh 3 and 1. So this is the mesh number 3, this is the mesh number 1, okay. So the common resistance is this one, okay. There is no other resistances common to both this loop. So here we have to consider this R3 is the common resistance. Therefore the sum of all the resistances will be R3. So if there are more resistances, then we have to add them and we have to put a negative sign in front of them. So here the value will be minus R3. So here we can write this is minus R3. We have got all the values of this resistance matrix. R11, R12, R31, all these values we have found out. I1, I2 and I3, these are the unknown values. These are the given EMFs, E1, E2 and E3. So in this matrix form, so R11 value is R1 plus R2 plus R3. We have already found out here. So R11 is R1 plus R2 plus R3. Sorry, this one will be, the value will be R2 plus R4 plus R5. R4 plus R5. So here we can see the self resistance is R2, R4 and R5, okay. So this is the R2 plus R4 plus R5. This value we have to put in the second row, second column, R2 plus R4 plus R5. In the third column also 3, 3, that is the self resistance will be R3 plus R5 plus R6 plus R7. So because we have already found out here the R3, R5, R6 and R7. These are the common resistances, self resistances of this loop. So we have put these values and we have already found out the values, and this will be the matrix. This will be the resistance matrix. Okay, this matrix is nothing but the R matrix. This is the I matrix, that is the current matrix, and this is the EMF matrix. So similar to the previous case, we have already found out this matrix. So if we want to expand this matrix for m number of meshes, so for m number of mesh, we'll have m number of row 1, 2, 3 up to m, and m number of columns. Okay, for the resistance matrix. Similarly for the I matrix also, if there are m number of meshes, we will have m number of loop currents, and similarly the m number of EMF values will be there, E1, E2 up to EM. For m number of meshes, this is the expansion of the matrix. This is the R matrix, this is the current matrix, and this is the EMF matrix. Or we can say that this is the voltage, this is the current, and this is the resistance. This matrix can be rewritten as what we can write: Rm into Im is the Em. This is nothing but the Ohm's law. R into I, resistance into current, is the EMF. So this is nothing but this is Rm, because we have m number of mesh. This is nothing but Im, and this is nothing but Em. This is the simplified form of this matrix. If we consider all the mesh currents in clockwise direction, then all the self resistances will always be positive. We have already seen all the self resistances. Now here you can see we have found out this is the self resistance, this is self resistance, this is the self resistance. These resistances will be positive. So this is the interpretation. Okay, all the self resistances will always be positive. All the mutual resistances will always be negative. We have seen that all the mutual resistance, that is, this is the resistance of the loop 1 with respect to loop 2, because this is the R12 value, this is the R13 value. These values are all negative. Here we can see these are the mutual resistances, this one mutual resistance. Okay, here also we have these two are the mutual resistances. That is, we have considered the first point is that if we consider the mesh currents in the clockwise direction, okay, you have to keep in mind. Now let us see a problem. Write the impedance matrix of the network shown below and find the current I3. I3 value means this is the I suffix 3. Okay, I3 value means the current in the loop 3. Okay, this one is the first loop, this one is the second loop, and this is the third loop. So these are the resistance values in ohm. 1 ohm, 3 ohm, 2 ohm, 1 ohm, 4 ohm and 2 ohm. We are given with the voltage source. This is the suppose 5 volt. We have to find out the current in I3, that is the loop current I3. We have to find out as per the question. Okay, so first of all, let us find out the various resistances. So R11 is the self resistances of the loop 1. So we have to sum all the resistances in loop 1. 1 plus 3 plus 2. 1 plus 3 plus 2. This is equal to 6. Now let us see R22. That is the self resistances of the second loop. 3 resistances, 1, 4 and 2. Okay, so here we'll have 1 plus 4 plus 2. Now let us see 1 plus 4 plus 2. Okay, so 4 plus 2 is 6 plus 1 it is 7. Now let us see the self resistances R33. That is the resistance of the loop 3 with respect to loop 3 itself. Okay, this is the loop 3. So here we have 3 resistances. This is the 3 ohm resistance, 2 ohm resistance, and this is the 1 ohm resistance. So here we'll have 3 plus 2 plus 1. So self resistance is the sum 3 plus 2 plus 1. So what will be the value? So 3 plus 2 is 5 plus 1, 6. So these are the self resistances values. Now let us find out the mutual resistances values. First value will be R12. This will be equal to R21. This is equal to negative of the sum of the common resistances. Okay, we have to see the common resistances between 1 and 2 loop. So this is the first loop, this is the second loop. Common resistance is this one. So this is the minus 2 ohm. So R12 is equal to R21 is equal to minus 2, because we have only one mutual resistances, okay, between the loop 1 and loop 2. So therefore this value will be 2 and will have a negative sign, because this is a mutual resistances. Now let us see R13 is equal to R31 is equal to, now we have to see loop 1 and loop 3. Okay, so loop 1 and loop 3. So this is the mutual resistances, only one resistance. So here we have only one mutual resistance, that is the 3 ohm resistance, and we will have a negative sign in front of it. Okay, so this value will be minus 3 ohm. Now let us see R23 is equal to R32 is equal to, so now we have to consider the loop 2 and loop 3, and we have to put a negative sign. Okay, now we have to find out the loop 2 and loop 3. This resistance is the common resistance among these two loops or these two mesh. This 1 ohm will be having a negative sign, okay, minus 1. These all are in ohm. You can write it here, ohm. Okay, so these are the values we have found out. Now we have to find out the in matrix form. So what will be the matrix form? So this R11 will be here. R11 value is 6. R22 means second row, second column. So this value is 7. And this R33 is the third row, third column. So here we'll have 6. R12 is equal to R21 is equal to minus 2 ohm. R12 means first row, second column. So this is minus 2 and this is minus 2. R13 is this one. Okay, R13 is equal to R31 is equal to minus 3. So this is minus 3 minus 3. This is R31, this is R13. Okay, R23 equal to R32 is equal to minus 1. Okay, this is minus 1, this is minus 1. This is the R23 value, this is R32 value. So here we'll have the three currents I1, I2, I. For the first loop we have 5 volt EMF source. Okay, 5 volt is the voltage. Okay, and the second loop and the third loop we do not have any voltage source. So for the second loop and the third loop, that is the E2 will be equal to 0 and E3 will be equal to 0. So for this loop we have E1 is equal to 5 volt, E2 is equal to 0 volt, E3 is equal to 0 volt. So here we'll have 5, 0, 0. So from this we have to find out the determinant of this matrix, and from that we will find out the I3 value, because in the question we have to find out the current I3 value. This is the third loop current we have to find out. This is the R matrix. Okay, this is the I matrix and this is the E matrix. So here we'll have delta. This will represent the determinant of the matrix. Okay, so here we'll have 6 minus 2 minus 2 minus 3 minus 2 7 minus 1, and in the third row we have minus 3 minus 1 6 minus 3 minus 1 6. So now we'll find out the values. This 6 will be multiplied with this method we have to see, because if we consider the first row first column, then we have to cancel out this first row and first column. Only we have to consider this part for this 6 value. So 7 into 6 it is 42 minus, so 1 into 1 and negative into negative positive, so it will be minus 1. Now negative sign for the second row will have a negative sign. Okay, now if we consider these two row, we have to cancel out these two and we have to consider this one and this part. This one you have to multiply and this one you have to multiply. Now again we have minus 2 here. Minus into minus it will be positive. Okay, plus 2 whole into, so here we'll have this minus 2 into 6, so this will be minus 12. Okay, and this minus 3 into minus 1, so this value will be 3 and we'll have a negative sign. Okay, so here we'll have minus 3 plus, so we have minus 3 here, so this plus will be negative. Plus into minus it will be minus 3 whole into. Now let us see the third row. So now we have to consider this is the determinant. Okay, so here we have to multiply like this. So minus 2 into minus 1, this will be 2 minus 7 into 3. Okay, this is 21, so we have a negative sign here, so this negative and this negative will be positive, so this will be 20 plus 21. So what will be the value of delta here? So this delta value will be is equal to, so the determinant value of this matrix will be equal to, this value is 147. Now we have to find out the current in the third loop, I3 value we have to find out. So we will find out the delta 3 value. So the determinant form, what we have to do, we have to replace the third delta 3 means third column we have to represent with the values of the EMF source. Third row will be replaced with this 500 value. This first two columns will be similar. So here we'll have 6 minus 2 minus 3. Okay, in the second row we have minus 2 7 minus 1, minus 2 7 minus 1. In the third column we have 5 0 0. Now let us find out the value. 6 whole into this 7 into 0, this is 0, minus this 0 into minus 1, this is 0. This minus and minus, it will be positive, so 2 whole into, so minus 2 into 0, it will be 0. Okay, and here we have this 3 minus 3 into 0, this will be again 0, plus now we have this 5 whole into 5 whole into minus 2 into minus 1, this will be 2. Okay, minus 7 into 3, this is 21, this will be positive now, 21. So therefore delta 3 is equal to, so this value is 115. Okay, so we have got the delta 3 value is 115. Okay, now for finding out I3 value, we have to divide this delta 3 value with the delta value. So I3 value will be equal to delta 3 divided by delta. So 115 divided by delta value is 147. This is the delta value. Okay, so we have to divide 115 with 147. This value will be 0.78231. This is in ampere. Okay, so this is the value of the I3. So this is the solution of the problem. So we have just formed this matrix. You need not to write these values first. You can directly put in this matrix, okay, from the loops. Then from this matrix you can find out the determinant values, and then you can find out the I3 value. Whatever be the current arcs, you can directly find out this value. Okay, so I3 value is 0.78231 ampere. In this video we have learned about the mesh analysis using matrix form. So if you have any question, please put it in the comment section below. Also like, share and subscribe to my channel. Thank you.